Okay. So, first chapter of your thermal physics is the kinetic model of matter.
Yes, sir.
Okay. So, in this chapter we will study describing solid, liquid and gases, describing changes of state. Okay, change of state we will do that, and explaining the kinetic model in terms of forces between particles. So, explaining the behavior of gases, calculating changes in pressure and volume. So, we will also calculate this one.
Yes, sir.
So, states of matter basically we have in lower class we will study that only 3 states of matter are there, but 4th state is also there. Okay.
Yes, sir.
So, but we will do that study in per stages. So, first one is solid state, liquid state and gaseous state.
Yes,
So, solid once it is converting into liquid, the process of converting solid into liquid, the process is said to be the melting. Okay.
yes, sir.
And liquid to gas, it is called as evaporation or boiling. Evaporation and boiling. And gas to liquid, it is called as condensing, and liquid to solid, it is called as freezing. Okay.
Yes, sir.
So now what we can say about its size and shape. If you talk about solid, occupies a fixed volume. Okay, like this is a pen, so we can't change its volume, we can't change its shape and size. It's a fix, isn't it?
Yes, sir.
Okay. So why they are fixed? Because there is very small gap in between the atoms of this solid. Okay. Your camera is switch off, I think. Please
What,
switch
sir?
it. Your camera is switch off. Please switch it on.
Okay, sir.
Okay. So now solid occupies a fixed volume. It has a fixed volume and a fixed shape. Your volume and shape, it can't be changed. Okay. And once we talk about liquid, it occupies a fixed volume. Volume is fixed, but takes the shape of its container. So whatever container you have, that will take its shape. Okay. Hello.
Sir, can you just repeat what you were saying?
Okay, you were not there. You were not there. So solid occupies a fixed volume as a fixed shape. You can't change its volume and shape. But in case of liquid, it occupies a fixed volume. Volume is fixed, but in whatever container you just take it, so it will take the shape of that container only. Okay. So its shape is not fixed. Once we talk about gas, expands to fill its container. So its volume is also not fixed, isn't it?
Yes, sir.
So you can fill 1 kg of gas in entire room or in entire house or in some large area. Okay. So its volume is not fixed, and also the shape. Its shape is also not fixed. So it takes the shape of that container. Okay.
Yes, sir.
So that is basically these 3 differences are there. So changes of state as I told you, once it is converting from liquid to gas or any of state is changing, so that is called as change of state. Okay. So melting is solid to liquid, boiling is liquid to gas, condensing is gas to liquid and freezing liquid to solid. Another term for a liquid changing to gas is a evaporation. Evaporation is also a term in which your liquid is changing to gas. Okay.
Yes, sir.
Okay. Okay, now why it is changing from a state to another state? Why solid is changing to liquid
So
state?
again, saving energy, right?
Yeah, because we are giving it energy. Okay, so we are just heating that solid compound. So if we heat that solid, it becomes a liquid at a certain temperature. Okay,
Yes, sir.
but every matter is having a different melting point. There is no fixed melting point of the same of the every material. Okay,
Okay, sir.
so whenever there is a change in state, there will be change in energy as well. Okay, so either it is losing energy, either it is gaining energy. Okay, so after losing or gaining energy only, that will be change in state, otherwise there will not be any change in state. So this is your temperature against time graph to show the changes that occur when ice is heated until it eventually becomes steam. So this is basically below 0 degree. So it starts from below 0 degree. Okay, so at 0 degree, what is happening? From here to here, it is solid. A to B, it is solid, and from here you can see here it's a steady graph. From B to that point, it is a steady graph. So what is why it is not changed to liquid?
Yeah, because initially is the boiling point, right? The melting point.
Yeah, before melting, it is attaining some type of energy, some type of heat it is attaining. Okay, so it is absorbing some type of heat. So that is said to be the latent heat of ice. Okay, you might have studied in physics also, latent heat. So this is also called its anomalous behavior of ice at 0 degree centigrade. Okay, so after some time, once it is continuously at 0, so it melts at point this point. Okay,
Yes, sir.
so it is changing its state from here to here. It is liquid. In this state, it is liquid. Again, it is not changing its state. It is liquid here for a particular time period. But if you keep on heating it, so it boils. Boiling is started at this point. Okay,
Yes, sir.
and from here to here it is boiling, but it is not changing its state.
Yes.
Got it? And here you can see it is changing its state to gaseous. So now what is happening from here to here? It is absorbing some heat. Okay,
Okay, sir.
that's why vapor are more dangerous than 100 degree centigrade of water,
Yes, sir.
because they have latent heat. So more heat vapor absorbs. Okay,
Yes, sir.
so you understood that graph properly?
Yes, sir.
Change of state, how it is happening. So now, yeah, this is the same thing what I told you. Same thing is written here.
Yes, sir.
So at a particular temperature, solid starts converting its state into liquid. So that point, that temperature is said to be the melting point. Got it?
Yes, sir.
And when a liquid changes to gas at a particular temperature, the temperature is said to be the boiling point. These are some melting and boiling point of gases. Helium melting point is minus 272 degrees Celsius. So that is very, very low. Okay. So it melts at minus 272 degrees Celsius. Okay. and even it boils at minus 269 degrees centigrade.
Yes, sir.
Okay, and your water melting point is 0 degree, boiling point is 100 degree. Okay,
Yes, sir.
diamond's melting point is very high, it's 4100, and its boiling point is 5400. Okay.
Yes, sir.
So the melting and boiling point of some pure substances, mercury is interesting because it is only metal, that is not solid at room temperature. It is not solid at room temperature, it is liquid. Tungsten is a metal and it has the highest boiling point of any substance. Helium has the lowest melting and boiling point of any element. In fact, helium will only solidify if it is compressed as well as cooled. So if you compress it and cool it, then only it will solidify. Okay.
Yes.
So as the warm liquid cools, its temperature is monitored by electronic temperature probe. The graph shows how the temperature of the octadecanoic acid drops as it cools. The temperature remains constant as the liquid solidifies. So that is the same thing. Okay, from here to here, its state is not going to be changed. So that is the same reason. It is absorbing some heat. Okay.
Yes, sir.
So how you can measure melting point? Carry out an experiment to determine the melting point of octadecanoic acid or some other pure substance. Use the method shown in figure 9.4. So is there lab practicals in your school?
No, sir, there's no practicals.
Okay, so we will not study that. Name the substance present in the section marked D. Look at figure. Okay. The kinetic model of matter. Now several questions arise from our discussion of changes of state. In this section we will look at the model for matter that provides one way in which we can answer these questions. So why there is a state of change? So why does it take time for a solid to melt? It is taking time. It is not just converting solid to liquid and liquid to solid, liquid to gas. Okay, but it takes some time. So why it is taking that time? So why does it take time for a solid to melt? Why does it not change instantly into a liquid? Because we are saying its melting point, boiling point of water is 100 degrees centigrade. So why it is not just converting into gas at 100 degrees centigrade? Okay, because of latent heat. It is absorbing some heat. So why do different substances melt at different temperature? So that is another question. Why do we have different melting point for different matters? So why do different substances have different boiling point? The same scenario. Okay. So we'll study all these topics into our next topic. Okay.
Yes, sir.
So the model we are going to consider is called the kinetic model of matter. As we saw in chapter 6, the word kinetic means related to movement. Okay. Atoms of any matter, they are moving inside a matter. Okay. So they have some sort of kinetic energy. So the model thus has an alternative name, the particle model of matter. It is, you can say it is a kinetic model of matter or particle model of matter, because we are going to study that particles, motion of these particles. Okay. So the particle of which matter is made are very tiny. They may be atoms, molecule or ions, but we will simplify things by disregarding these differences and referring only to particles. So we will say only particles. We will not say atom, molecule or ion. We will say it only particles. Okay.
Yes, sir.
So we will also picture a material as consisting of large number of identical particles. So these are identical particles because in a matter all particles are identical. They have same type of atoms or molecules, so they all are identical. Okay.
Yes.
So whose particles are the same, rather than a mixture that contains two or more types of particle, we will also picture the particles as simple sphere. So particles we can take it like a sphere. Okay. Although in reality they might have more complicated shapes. Shapes are different. It is not always like sphere, but we are taking it in this example or kinetic theory of matter. We'll take it only like sphere shape. Okay.
Yes, sir.
So the idea that matter is made up of spherical particle is a great simplification, but we can still use this idea to find answers to these questions. So we'll have to find the answers of that particular questions was written there. So now first of all, the arrangement of particles. You can see this is the structure of these are three structures. So in this structure you can see the gap between these particles are very small. Gap here is some more, but here you can see gap is very high. So we can say this is a solid form, this is a liquid form, this is a gaseous form.
Yes, sir.
So okay, so in terms of space between particles, your solids will have a lesser space in between particles, or you can say it's a nominal space, or you can say it's a very less space in between particles. But if we go to liquid, so it has more space in between particles. In gaseous, it is very large space in between particles. Okay.
Yes.
So that's a one kind of distinction between solid, liquid and gas in terms of distance of particles from each other. So in solid, liquid, I already told you these are the structures of. Okay, now this is arrangement of particle. Now we'll talk about movement of particle. Okay, if they are tightly packed, can they move? If the particles are tightly packed, can they move here and there? There is no space. There is no space to move. Okay, so
Yes, sir.
they can slightly just moving. Because the particles are so tightly packed, they can't move around. However, they do move a bit. Yeah, they just shake it. They are able to vibrate about a fixed positions. So they are only vibrating.
Yes,
Okay.
sir.
So the hotter the solid, the more they vibrate. So whenever we are giving some energy, whenever we are just, so what they are doing, they are just vibrating at the same position because they don't have space. Okay.
Yes, sir.
Okay, but now in case of liquid, they have some slight space between them. So because the particles slightly less tightly packed than in solid, they have the opportunity to move around within the bulk of the liquid. Hence the particles are both vibrating and moving from one place to another place. So in solid only they are vibrating, but in liquid they are vibrating and even they are moving. Okay, got it?
Yes, sir.
Okay, but in gaseous, the particles are now moving freely about, bouncing off one another and off the walls of their container. So sometimes they hit that wall of the container, they hit again, they hit this wall of container, some bottom, some roof. Okay, so they are moving freely in gaseous. So approximately their in air at room temperature, their average speed is 400 meter per second. So that is very high speed, 400 meter per second. It's a speed of particle of air in a room. Okay.
Yes.
So an experiment arrangement for observing browning in motion. The grains of smoke are just large enough to show up under the microscope. The air molecules that collide with them are much too small to see. Okay, so this is an experiment in which you can see movement of the particles. Okay.
Yes, sir.
Okay, just I'll tell you what is outcome. Smaller than the smoke grain, in other words, they are very light compared to smoke grain. And the
Well, I don't think this is needed, sir. I don't think this example is needed.
Okay, it is not in your syllabus.
No,
Okay. So now explanation using the kinetic model. Liquids take up the shape of their container because their particles are free to move about within the bulk of the liquid. Gaseous fill their container because their particle can move freely about. So it is basically the kinetic model. Okay. So we are just combining all these things. So that is a kinetic model. Gases diffuses from place to place, so that for example we can smell perfume across the room. The perfume particles spread about because they are freely mobile, they can move it. Okay.
Yes, sir.
So similarly, dissolved substances diffuse throughout a liquid. Sugar crystal in a drink dissolve and molecule spread throughout the liquid, carried by the mobile particle. In a hotter drink, the particles are moving faster than the sugar diffuses more quickly. If you give some heat, so they diffuses quickly. Okay. So most solid expand when they melt, the particles slightly further apart in liquid than in solid. So that is basic thing. Liquid expand a lot, so the same thing. If you are just heating the liquid, so it becomes a gas. Okay, after evaporation. So their particles are very large distance. Okay. Now evaporation. Any doubt in evaporation? I think it is very simple. Evaporation is a process in which your liquid is converting into gas, and the temperature at which it converts into gas, it is called as boiling point. Okay.
Yes, sir.
But it doesn't start quickly at the boiling point. It takes some time.
Yes, sir.
Got it? Okay, now why evaporation make things cooler?
Well, because like the kinetic energy of the particle causes the molecules to rise, right? After it has risen, the energy decreases, right?
Yeah, so the energy decreases, that means your temperature is going down. Okay. So they are taking energy and they are going. So whatever particles we are having, so that particle will be having a lesser energy. So why is the kinetic model of matter called kinetic? Because particles are moving. That's why it is called as kinetic model. In which state of matter do the particle have the most kinetic energy?
Gas.
Gas. Okay. In which state of matter are the particle most closely packed?
Solid.
Solid. Very good. Okay. So they are simple things. Use the kinetic model of matter to explain why we can walk through air and swim through water, but we can't walk through a solid wall, because there is no space.
Yes.
Okay. So now we'll talk about forces and the kinetic theory. So why all the particles are stick together? Why they aren't moving away? Because
Force of attraction, right?
because there is a force between these particles, so all particles are attracted by the force. So that is an attractive force between them. So without attractive force to hold together, the particle make up matter. So we will live in a very dull world. There would be no solid or liquid, only gases, no matter. So you can see the moon. On moon there is no solid and liquid, only the gases.
Moon.
Yeah, on moon no gas, no solid, no liquid.
So what about like the moon? You can step on it, right? Isn't that solid?
Which one?
On the moon, isn't it solid? Because like you can step on it, right?
Yeah.
The rocks on the moon and all that.
But no matter is there. Matter is not there because uh, atmosphere cannot be there because their escape velocity is very small. So no gas
So
can.
it's not really like state of matter.
Yeah. Because gases also cannot survive there.
Oh, so there's no solid, liquid, or gas on the moon?
Yeah. Liquid converts very fast into vapors.
Isn't the moon a rocky body though?
Yeah, but there are no minerals.
Okay.
Okay.
Yes, sir.
Naturally, nothing is there. Okay.
Okay, sir.
No atmosphere, no gas.
Okay, but what this? It's what about the exosphere, sir?
Exosphere?
Yeah, like the atmosphere of the moon.
Atmosphere of the moon. Actually, uh, no gas is present there at moon.
No, but like, what about helium, neon, and argon, sir?
Nothing is there.
Okay. Like we searched it online, it says helium, neon, and argon are there.
It is there at moon.
Yes, sir.
Okay, we'll clarify it after study. I'll study there. Okay.
Yes,
I'll
sir.
come to know you. Okay, so another way to refer these forces is to say that they are having bonds also in between atoms, in between particles. They have bonds and attractive force. So because of bond, weaker the force, greater the bond, greater the force. Okay.
Okay, sir.
Now kinetic theory and changes of state. So once you give energy, it changes its state from one state to another state. Or you taking some energy, so that also changes the state of matter. Okay. So only one thing is there. So if there is change in energy, so matter of state can be changed. Okay.
Yes.
Okay, now it is just about evaporation. As a gas is cooled, it start to condense, the particle moves slowly and they start to stick together because of the attractive forces between them. As their energy gets less, they clump together in bigger and bigger groups. Finally, they form a liquid. Okay. So it is condensation of gas. It becomes liquid if you cool it down. Okay.
Yes, sir.
Okay, a liquid evaporates more rapidly when it is hotter. At a high temperature, more of the particle of the liquid are moving fast and have to escape from the surface because
So more energy.
they have greater energy. Okay,
Yes, sir.
and whenever it is just you spread the liquid, it evaporates more quickly because more surface area is there. So with a greater surface area, more of the particles are close to the surface and so they can escape from easily. Okay.
Yes, sir.
Liquid evaporates more quickly when a draught blows across its surface. So draught is moving air, it's a moving air. Okay. So when particles escape from the water, they are blown away so that they cannot fall back into the water. So that's why it is gone. Now more about evaporation, we talked about it. Now there are questions. Okay. Just try to answer these questions. Go through that. If you have any doubt, just ask me.
Yeah, because melts at a much higher temperature, that means the force is stronger if it dumps in atoms.
Yes.
Yes, I understand this.
Okay. 12th one.
Oh, yeah, I think it's an insulator, sir, right? The temperature does not rise.
No,
But
it's
that
not.
means
It's not an insulator. It's a solid material. A particular solid metal is heated, but its temperature doesn't rise. Yeah, it is. It is an insulator. Okay.
Yes.
If a gas is heated, its molecules move faster. Use the kinetic model to make the prediction what will happen to the pressure that the gas exerts on the wall of its container when the gas is heated. So if you heat a gas, it applies more pressure on the walls of container. Okay,
Yes, sir.
because they want to escape. Now gases and the kinetic theory. Why does a gas exerts pressure? Because the particles tend to move. Okay. If there is some obstacle, they will apply pressure. What happens to a gas when it is heated? If you heat the gas, it will expand. Okay. The particle will move more faster, more pressure they will apply. What happens when a gas is compressed? So what is happening once gas is compressed?
The particles move closer together, right?
Yeah, they are just,
Sharing places.
you are making that particles closer. So if they are more closer, then they can be converted into solid, liquid as well as solid if you compress it more. Okay.
Yes, sir.
So these are the things. Inflating a balloon, as you blow, the pressure of the air inside the balloon increases, that's why it inflates. Okay.
Yes.
Okay, now compressing a gas, I told you how compressing a gas is done. Okay, now there are certain things that will change. So look at the figure 9.10a. If half of the particle of the gas were removed from the container and nothing else was changed, how would the following properties of gas change? Okay, if you compress the gas, what is changing? What parameters?
Pressure.
Pressure is changing. Yeah, pressure will be more.
Yes, sir.
And what about density?
Density will.
If your particles are more closer, then density will be more.
Oh, yes, sir.
Why we say if there are more population, Shanghai is a most populated city in the world. Why we are saying? It is a more density, much higher density. Okay. So density is the thing per unit volume. Okay.
Yes.
Density is mass by volume. So its density will be increased if you compress a gas. And pressure will also be increased. Pressure will be more if you compress it. Okay. What about temperature?
Temperature. Oh yeah, that will also cause the gas to the pressure to increase, right?
Yeah. So that will depend. That
Yes,
will
I
depend.
understand.
Okay. If gas is expanding quickly, then your temperature will drop. Temperature will drop. Okay. If it is expanding quickly, like your tire burst. So if your tire burst, so your gas is expanding quickly. So that part of the burst will be very cool. Okay.
Yes, sir.
Now, once we are talking about pressure and volume, so there is a law how they are relating to each other. So the first law is Boyle's law. So it is basically about the pressure and volume. So if you increase the pressure, what will be happening to the volume? If
That will also.
you compress the gas, what you are doing? You are just increasing the pressure.
Yes, sir.
So what is happening to the volume?
It decreases.
It decreases. So that means P is inversely proportional to V, isn't it?
Yes, sir.
So that means P is inversely proportional to V. If you increase P, V will be more. If you decrease P, your V will be less. So that means PV. That means PV will be a constant, isn't it?
Yes, sir.
So that law is said to be the Boyle's law. At a constant temperature, pressure of the gas is inversely proportional to the volume of the gas. Okay?
Yes, sir.
But at a constant temperature. Got it?
Yes, sir.
Okay. So doubling the pressure has the effect of halving the volume. 3 times the pressure gives 1/3 of the volume, because PV must be constant. PV must be constant. Got it?
Yes, sir.
So PV will be constant. So what happens if your pressure is doubled? If your pressure is doubled, so volume should be halved.
Yes, sir.
Then only it will be equal to PV. Then only it will be constant. Okay. So in whatever ratio your pressure is increasing, in that particular ratio your volume to be decreased, isn't it?
Yes, sir. Yes,
So
sir.
that is the meaning, because there they should cancel each other. So if you increase pressure 8 times, your volume will be decreasing 1/8.
Yes, sir.
Okay,
So, okay.
got it?
Yes, sir.
How, whatever pressure you are, because their product will be same, product will be constant. Its product will be PV always. Okay.
Yes, sir.
So if you are decreasing pressure 2 times, so then your volume will be increasing 2 times. Whatever decrease in pressure, increase in volume. Whatever increase in volume, pressure will be decreasing. Okay?
Yes, sir.
Because their product will be going to be a constant value. Just note it down, it is Boyle's law.
Yes, sir.
PV is equal to constant. Because we'll do more questions on that law.
Oh, sir.
So basically we calculate P1 V1 equal to P2 V2 in 2 scenarios. Once 2 scenarios will be given, so we'll calculate it. Just calculate this example 1. In Boyle's law, just remember that they will talk about only pressure and volume.
Okay, then cylinder conducts 50 centimeter cube, pressure of 120 kPa. Pressure if is increased to 400.
So you can use P1 V1 equals to P2 V2 because every time.
So 120, I can do 120 times 50 divided by 400, right?
Okay, what is your answer?
I'm getting 15 centimeter cube.
15 centimeter cube. Okay. Yeah, it is 15 centimeter cube. But just remember, all the units you are taking, they must be the same. Okay.
Yes, sir.
Okay, just try to do these questions. 18.
Subscript is like P1, the first pressure, first volume.
Okay.
Yes, sir.
So the pressure on 6 decimeter cube of nitrogen gas is doubled at a fixed temperature. What will be its volume become? So if pressure is doubled, so
we half, so half of 6, 3.
yeah, 3 will be there. Okay.
Yes, sir.
19.
Which one? Oh, this one, okay.
Pressure is increased to 2.5 times. So
Yes,
volume will be decreasing by 2.5 times. So 600 divided by 2.5.
Yes, sir.
Okay.
Yes, sir.
So that will be the answer. And 20th.
Gas in 15 divided by 0.15 divided by 0.05. Yes, I'm getting 800 kPa.
800 kPa.
kPa.
Okay, good.
Yes, sir.
So you got it now? How we
Yes, sir.
calculate? How we calculate by Boyle's law?
Yes, sir.
I think your chapter is finished.
There is so thermal physics has 2 more chapters, sir.
Okay, yeah, we'll do that. Just try to answer these questions as well. Okay.
Okay, sir. Yeah.
Okay, now in this chapter we are going to study about measuring temperature. We'll measure temperature by the help of thermometer. It's an equipment to measure temperature. Understanding and using thermometers. Designing thermometers, describing the thermal expansion of solid, liquid and gases, explaining some uses and consequences of thermal expansion. So now measuring temperature. Why we require to measure temperature? In fever also we measure temperature. Okay, for
Yes.
human body it is basically 98.3 some Fahrenheit, degree Fahrenheit temperature. It is a normal temperature of body. But as it go up, our body gets heated. Okay.
Yes, sir.
So the person wants the water to be at body temperature about 37 degrees centigrade. She or he is using the fact that there are nerve ending in the skin. That so basically our body temperature is basically 37 degrees centigrade inside. Inside temperature is 37 degrees centigrade. So if we consume anything which is 37 degrees centigrade, so that means it is at the level of our body temperature, inside body temperature. Okay. So
Yes.
why we say just don't take too much of ice cream and that in
Reduces the body temperature.
because it affects the body temperature. Okay. It cools down our body very fast. So these are some measurements. Okay. Measurement of temperature. Measuring human body temperature using a liquid in glass and be liquid crystal thermometer. It is a liquid crystal thermometer. Okay, I have not seen this one, crystal one. I have seen this liquid one. Okay.
Yes, sir.
So temperature and temperature scales. So temperature is being measured in 3 scales, or you can say 3 units. One is degree centigrade, Kelvin and Fahrenheit. Okay.
Yes, sir.
So in thermometer, what is the unit?
Thermometer degree Celsius.
Is it actually degree Celsius?
No, it's Fahrenheit, right?
It is Fahrenheit. We say you have fever 102 or 103. It's not in degrees. It is in Fahrenheit. Okay.
Yes.
102 degree is very hot. Everything will be evaporated from your body.
Yes, sir.
Okay.
Yes, sir.
So thermometer probe will have to be very small. If you make it very large, what it will do? It will absorb more energy. So it will not give you the correct measurement. So this is basically thermometer. So one is Celsius scale. So internal energy is the total energy of all the particle. Temperature is a measure of the average kinetic energy of the individual particle. Okay. So temperature is nothing but it is a measurement of hotness and coolness. Okay. So how you are going to calibrate a thermometer?
No, sir.
You will be having temperature is already 0 degree centigrade. Okay. So
Yes, sir.
we take mercury in a glass tube. Okay.
Yes, sir.
So we mark the level of mercury. So it will be marked as 0 degree. Okay.
Yes, sir.
So we just design it with the help of known temperatures. Okay.
Okay.
So that is the calibration of calibrating thermometer, or you can say so mercury is sealed in that thermometer. So two buckets contain water at 30 degrees centigrade. One contains 1 kg of water and the other contains 2 kg of water. State the explain whether the following quantities are the same or different for the water in the two buckets. Just tell me these the answer of the first question.
Okay. Internal energy is wait. So the internal energy is lower for the second one, right? 2
Okay.
kgs,
Because it is 2 kg of water. Number of molecules are more.
yes, 1 hour molecules.
Okay, and what about the temperature?
Temperature is the same.
Okay, because temperature is the average energy of a molecule.
Yes, sir.
And what about C part, average energy of a molecule?
Energy. Well, average energy is more for 1 kg, right?
Average energy of a molecule. Number of molecules are more in second one, but in 1 kg it is less. So average energy is not going to be changed. It is same for every molecule. Okay?
Okay, sir.
Okay, what are the two fixed point on the Celsius scale? 0 and 100?
Yes, sir.
Write step by step instructions for the calibration of thermometer using Celsius scale. Okay, we'll calibrate it according to the prefixed temperatures.
Yes, sir.
Okay, now designing a thermometer. Mercury in glass and alcohol in glass thermometer are used in many different situations. They are attractive for a number of reasons. Okay. Mercury expands at a steady rate as it is heated. This means that the mark on the scale are evenly spaced. We say that the scale is a linear. So mercury heated with a constant rate. Okay.
Yes, sir.
So its graph is linear. As you heat it up, its temperature rises. So it is a linear graph. So the thermometer can be made very sensitive by making the tube up, which the mercury expands very narrow. Then a small change in temperature will push the mercury a long way up the tube. Okay, if you want to make it very sensitive, so that means you need to make a very long tube. Okay.
Yes, sir.
It will be a very thin tube. So your mercury will go very up. So that means for a change in 1 degree centigrade, you can see it clearly. Got it?
Yes, sir.
So you can make it sensitive. So mercury thermometer can have a wide range because mercury is liquid between minus 39 degrees centigrade to 350 degrees centigrade. It is a liquid. Okay.
Yes, sir.
Some domestic ovens have mercury thermometers that read up to 250 degree centigrades. The problem with mercury thermometer is that they have to be read by eye. It can't be digital. Okay. An alternative is to use an electronic thermometer. Some of these are based on thermistors. So they are based on thermistors. Thermistors we have studied in the previous class.
Yes. Yes, sir.
Which are resistors whose resistance changes by large amount over a narrow temperature range. These can be very useful, especially as they are robust and can be built into electronic circuits. Okay, they are robust.
Yes.
But what about your mercury thermometer? They are
What happened, sir?
just a moment.
Yes, sir.
Okay. Actually, someone commented on my video. We are live on YouTube as well.
So what is that?
Someone is writing Ishrafil Gori. Mercury is a naturally occurring chemical element found in rock in the Earth's crust, including in deposit of coal. On the periodic table, it has the symbol Hg and its atomic number is 80. Okay, but we are not bothered here about its chemical properties. Okay.
Yes, sir.
A glass tube is filled with mercury and a standard temperature scale is marked with tube which in temperature. Okay, so she is also saying the same thing. Okay.
Yes.
So if we have electric thermometer, so it is very robust in nature. Okay,
Yes, sir.
rather than the glass filled mercury, because it is very sensitive. If it is dropped down, then it will break. Okay.
Yes, sir.
So the electrical resistance of a thermistor change over a narrow change of temperature. This means that can be used as a temperature probe for an electronic thermometer. However, it will only be sensitive or narrow range and its behavior may be non-linear. So actually this thermistor is used in ACs, refrigerators to maintain the temperature. Okay. Wherever you want to maintain the temperature, so their thermistors are used. Okay.
Yes, sir.
Okay. Any doubt till now?
No, sir.
Okay. Yeah. So this is about thermistor. So what was happening in case of mercury thermometer? That was changing linearly. But you can see here it is not a linear graph. Okay.
Yes, sir.
So it changes very rapidly from, you can see, 40 to 50, 40 to 60, 40 to 60 degrees centigrade, its resistance changes rapidly. Okay.
Yes, sir.
And from 70 to 100 degree, its resistance is almost same. Okay.
Okay, sir.
So the resistance of thermistor changes in a non-linear way, so that the intervals on a scale will not be all equal in size. So the range of such a thermometer will be narrow. So its range will be narrow because we want a linear graph, isn't it?
Yes, sir.
Because if it is not a linear graph, then we can't calculate the value of temperature. So the range of such a thermistor will be narrow because the resistance only changes significantly over a narrow range of temperatures. You would need to choose a thermistor whose resistance changes most near the temperature you were trying to measure if you want to the thermistor to be sensitive. Okay. So the second alternative is to use a thermocouple, a device that gives an output voltage that depends on the temperature. So whatever is the temperature, that output of that thermocouple is going to be changed. Okay.
Yes, sir.
So understood that things.
Yes, sir.
Okay. So whatever is remaining will cover in the next session.
Okay, sir.
Okay. Next session will be on Tuesday at 5.
Sir, are you free this week also? Because exams are coming soon, so I think we might need one more this week. What time are you free this week, sir?
This week. This week